I'm Kevin Rondo, and welcome to Rondo Pools and Spas educational series, Water Chemistry. Keeping your water balanced is going to be very important for three main factors. You want your water clean and clear, you want it refreshing to swimmers, and you also want to protect your investment long term. Poor water chemistry can damage your interior finish, make it stained, scaled, spot etched. So keeping your water balanced is going to protect this investment long term. For Rondo Pools, we recommend the Taylor Complete Test Kit. It tests for the 5 main tests that we always recommend to our clients. So let's start by taking an in-depth look at the test kit. This is the Taylor Complete Test Kit made by Taylor Technologies. This is the test kit that we provide all of our new pool clients. It's an excellent test kit. It tests for the 5 major tests that any pool owner should be taking to take care of their pool. Very similar to what a pool service company should be using. I do not recommend the test strips that are commonly available. These droplets in the comparator tube and the vials are going to give you much more accurate tests. So I definitely recommend using this type of test kit. We want all of our clients to be really comfortable with taking care of their pool water. So we give them the best test kit available. Now, walking you through it, this test has 5 different tests, and you can see they're all color-coded. The vials or caps are matched to the color of the test. So the first test is chlorine, using the yellow vials. The next test is pH, using the red vials. Green, total alkalinity. Blue, calcium hardness. And white, cyanuric acid. So the instructions are clearly written for each test. Most of the time you need to read the instructions the first time through, but after doing each test a half dozen times or so, you'll be very comfortable and know exactly how to perform each test without reading through the instructions each time. One of the big helpful parts of this kit is there's a really great pool water chemistry book. Gives you a really good in-depth review of water chemistry, everything to know about it. Let's dive in and take a look at some of the key features with this book. This is the Pool and Spa Water Chemistry book that comes in the Taylor test kit we provide. I recommended any new pool owner take a full read of this book. It's really going to give you great education on what you need to do to take care of your pool. A great introduction to water chemistry in general, discuss each test and why our water needs to be in those ranges and what happens when they're not. Some of my favorite highlights of this book. On page 44, we have the recommended guidelines. This gives us all the tests, all the recommended ranges for your water. So a great reference point when you're trying to determine where your water needs to be. But my favorite part about this book comes at the back with the tables starting on page 53. Each of these tables is going to give you exactly what you need to do to bring your test results into the right range. Now that you're familiar with your test kit and all the tests we're going to do today, let's jump into that first test, chlorine. So the first time through, you're going to probably want to read all the instructions line by line, get familiar with the bottles, but as we mentioned before, all the bottles that you'll be using are going to be color-coded to the test. So in the first test, chlorine, yellow, we're going to be using these 3 yellow bottles. If you follow the instructions, this is going to be referred to as the comparator tube. So we're going to use this to do the test. In the first test, it asks us to fill and rinse the small comparator tube to the 9 milliliter mark. I always recommend getting down to your elbow, getting a little bit deeper sample. Taking surface water for your sample might give you a little inaccurate readings. So we fill it up, shake a little water out to get to that 9 milliliter mark. We add 5 drops of the R001. And 5 drops of the R002. This cap and mix. I don't recommend using your finger. I recommend using the plastic caps. There is oil on your fingers that could affect the test. So keeping it accurate. Now we compare our readings to the color readings on the recommended chart. Right now I'm reading about between 0.5 and 1 part per million. That's actually perfect for me, and that's what I'm looking for. Depending on the time of year, you want higher or lower levels. This is March, so going into the season, I try to keep it on the low end of the spectrum. Mid-season, I'll bring it up to the high end of the spectrum, but I also have an ozone unit that helps me keep my recommended levels lower, so this is a perfect reading for me. The next part of the test is the combined or total chlorine part of the test. So we take this existing test reading that we have, knowing that we're at 0.5 to 1 part per million, and we're going to add 5 drops of the R0003 reagent. Cap and mix. Now this result is going to give us our total chlorine. Ideally, we want our free chlorine and our total chlorine to be exactly the same. If there's a difference between the free and the total chlorine, that means we have a buildup of what they call combined chlorine. And that combined chlorine are the chloramines that's going to irritate your skin and give you all the negative attributes that you associate with chlorine. So our goal is to keep the chloramine count at a 0. Again, my ozone unit helps eliminate those chloramines. So I'm going to do a comparison again, and I'm looking at the same reading that I had with my free chlorine. So I know I have 0 combined chlorine, which is what we're looking for. If your chlorine is low, you can refer to the tables in the back of the book, as I mentioned previously, and it'll help us determine how much chlorine we need to add. Most pools have a little bit of personality, so you'll know how many tablets that you'll need to keep in the pool on a regular basis during different times of the year to maintain that chlorine count as you need. The next test we're going to do is the pH test. While the first test was testing chlorine, that's our sanitizing agent. The pH test is more of a balance water chemistry test. So you've heard the term water balance. So we're testing the pH level, which is the acidity or alkaline level of the water. High on the pH scale, the water is too alkaline. That's going to result in water that's going to be scaling, cause scale buildup and staining. Low pH means the water is too acidic, which is going to lead to spot etching, aggressive water, a little bit more irritating water to the swimmers. So keeping your water balanced is going to be key to refreshing water and taking care of your investment long term. So with this test, we rinse and fill the large comparator tube to the 44 milliliter mark up top. This is one of the easier tests, just 5 drops. Cap and compare. Then we compare our reading of our water to the compared colors in the pH scale. In this test, you're looking for peach-colored water. If the water is acidic, it's going to be really yellow. If it's too alkaline, on the high pH scale, it's going to be really pink. So having peach-colored water is really ideal. Mine is reading right around the 7.6 mark, so it's really peach and a perfect test. Now, if the pH level was too low, and you're getting more of a yellow color in your reading, that means the water is too acidic. So we're going to add soda ash. It's the most typical chemical that you add to raise your pH level. In Arizona and most areas, pH has a tendency to just kind of creep up on you, so you're going to see high pH readings a little bit more often. And then we're going to bring those levels down by using muriatic acid, a very common chemical that you'll have on hand all the time. So the nice part about this test, using the test kit and these droplets, they can tell you how much acid or how much soda ash you'll need to add. The acid demand reagent, which is the R0005, like I said, if your level is too high and you're seeing a real pink test, you add the acid demand reagent and you count the number of drops. Rinse, mix. You can see that brought my level down way too low to the yellow range. So you count those drops. It takes you to get to the right range. Adversely, the base demand reagent if we need to add more alkaline to bring it up. Get it in the right range. So use those drop counts compared to the tables in the back of the book with the gallons of the water, and they'll be able to tell you how much acid or how much soda ash you would need to add to get you the right range. So our key is to keep it in that 7.4, 7.6 range as often as possible, pretty consistently. Know that when your levels get out of the range too often and you get high, low, that's going to lead to other issues. So the goal is to test your pool regularly and maintain that range as much of the year as possible. The next test we'll be doing is the total alkalinity test. Total alkalinity is really the water's ability to maintain a proper pH. So while the pH is the acidity level or the alkaline level of the water, the total alkalinity is similar, but it acts as a buffer for the pH. With the total alkalinity in the recommended range, which is 80 to 120, your pH is going to be very stable, easy to control. It's when the total alkalinity is outside of that range, high or low, that you'll get what's called pH bounce. Your levels will go high, and then you add the necessary acid, and then it's too low, and then it's too high, it's too low, difficult to maintain. So getting your total alkalinity in the recommended range first will help you keep that pH level pretty consistent year long. So let's dive in with this test. A little bit different than the previous tests. We're going to do a little bit of color matching, but in a swirl. So with this test, it actually has us add 25 milliliters of water to the large comparator tube. So we're only filling this large comparator tube halfway. We add 2 drops of the first green bottle, which is the R0007. And 5 drops of the R008. Now with this test, it asks us to swirl and mix. So we're really swirling and mixing this water, and it starts off with a really green color because that second vial is very green in nature. Then what it has us do is we add 1 drop at a time of the R0009, and we count the number of drops it takes us to get this sample from turning green to pink. And you just count. 1, 2, 3, 4, 5, 6, slightly pink, 7, very pink. So we multiply that number of drop count by 10, and that's our total alkalinity mark. So for me, that's 7 drops. That is 70 parts per million. I'm slightly low. As with the other tests, we can go back to our book, refer to the table. Table E, which I use all the time. Ideally, I'd like to bring mine up to the 100 mark from 70, so I need to raise 30 parts per million. I know that I have 15,000 gallons of water. So basically, I need to add the 5,000 and 10,000 gallon columns together, and I need to add about 6.5 pounds of baking soda to bring me up to that 100 part per million. So very important to try to keep that in the right range. That's something that you should do as part of your weekly tests. I say every week we test the chlorine, the pH, and the alkalinity. The next 2 tests we'll do is something that you can do on a monthly basis, but that will bring us right to where we need to be for every week. The 4th test we're going to be doing today is calcium hardness. A calcium hardness test measures the amount of calcium that's solution in the water. Every day you're evaporating water from the pool, the minerals and the calcium stays in the pool, and through your water level you're adding more and more calcium. So over the course of the year your calcium is just going to slowly increase. There's really nothing you can do about it. The goal is to maintain the proper range so you don't get that calcium buildup along the edge of the pool line, water features, and such. Once the calcium saturation gets to a certain point, there's really nothing you can do. It will just get out of solution, it'll crystallize on the water line, and that's when you see all that calcium buildup that you're trying to avoid. So, keeping your pool water in the right range on the calcium scale is important. The only way to get rid of calcium is to drain the pool partly or entirely and refill with fresh water. Me personally, I drain my pool every year, fill it with fresh water, typically every April or May. Get ready for a good full swim season, and you're good to go. So let's dive into this test. This test is very similar to the total alkalinity test in terms that you'll be swirling and mixing and comparing colors. Now this test gives you an option for anticipated high level. You know, I personally know that my calcium level is very high. So the main test will have you rinse and fill it halfway. If you're anticipating high levels like I am, I'm only filling it to the 10 milliliter mark, and we just use a different multiplier. So in the high level anticipated range, it has us add 10 drops of the R0010. Swirl and mix. And then 3 drops of the 11. The sample initially turns pink. Then we are going to count the number of drops of the R0012 reagent. We need to go from pink to blue. The result I'm looking for. So it took me 30 drops. It has us multiply that number by 25. So my calcium hardness right now is 750. That is much higher than I'd like it to see. The recommended range is 2 to 600. So whenever I'm above 600, you know, I'm planning on draining. Like I said, it's March. I'm planning on draining my pool here over the next month or two. So I may move up that timetable a little bit with that test result. So ready to drain the pool. So like I said, keeping that calcium hardness range in the recommended level will help protect your pool from all that calcium buildup that you're trying to avoid. The fifth and final test we'll be doing today is cyanuric acid. Now, cyanuric acid is commonly referred to as chlorine stabilizer. Chlorine stabilizer is the fifth and final test we'll be doing today is our cyanuric acid test. Now, cyanuric acid is commonly referred to as chlorine stabilizer. Chlorine stabilizer or cyanuric acid is essentially a UV protectant for the chlorine in the pool. So if you have chlorine stabilizer in the pool at the proper levels, your chlorine is going to be a little bit more effective. It's going to last longer. Too low of levels of chlorine stabilizer and the sun will eat up the chlorine and it won't be effective enough in the pool. Too much chlorine stabilizer will actually bind up the chlorine. It's preventing the chlorine from working, almost like putting 3 pairs of sunglasses on your chlorine. It's just not going to be able to see and work. So, to do the cyanuric acid test, we're going to use this small vial. It's got a 7 and a 14 milliliter line. What we do is we fill the vial up to the 7 milliliter mark. Then we have actually a couple bottles of this because we use a lot of it. It's the R0013, and then we take this chemical and fill it all the way up to the 14 milliliter mark. It says mix thoroughly. Requests you to mix it for 30 seconds. Now, the small comparator tube, you'll see that there is a black dot at the very bottom of the tube. What we're going to do is we're going to take this, after we mix it, it's going to turn a little cloudy. Once we do that, we're going to slowly pour it into this small comparator tube, and we're going to try to just watch until that black dot disappears. Once that black dot disappears, we're going to take a reading off to the side of the vial, or the comparator tube, and see where our mark is. Just disappeared. Taking a look, looks like we're right around the 50 parts per million mark. The recommended range for cyanuric acid is 30 to 50, so we're at the top end of the range. I mentioned that a lot of our clients are using stabilized tablets. Stabilized tablets are basically chlorine tablets that have a little bit of cyanuric acid mixed in each tablet. It helps those individual tablets be a little bit more effective. However, over the course of a year in using stabilized tablets on a regular basis, a lot of our clients will see that cyanuric acid level rise too high. So it's very important that we keep an eye on that cyanuric acid level. I test every month just to keep a tab on it. The only way to get rid of cyanuric acid when the level is too high, similar to the calcium hardness, is to drain the pool. So typically once a year we're draining the pool. It refreshes our calcium hardness level, it refreshes our cyanuric acid level, but it's something that we want to keep an eye on with the rest of the test. A side note that I like to talk about cyanuric acid is there's a test that's commonly ignored, which is very important to the quality of the pool. There's actually an adjustment that can be made to your total alkalinity when your cyanuric acid is too high. So, not to confuse, but what you do is you take 1/3 of your cyanuric acid level and subtract it from your total alkalinity to give you your true total alkalinity. If you remember from my test before, I tested my total alkalinity at 70. I just tested my cyanuric acid level at 50. So if I take 1/3 of my cyanuric acid level, it's about 16 thereabouts, and subtract it from my total alkalinity, my true total alkalinity is not 70, it's closer to 54. Now, that's too low. When your cyanuric acid levels are in the right range, 30 to 50, a 10 to 15 point adjustment in your total alkalinity is not going to be that big of a deal. So if you're at 100, your true total alkalinity is still in the correct range at maybe 90 or 85. However, I see a lot of customers that have cyanuric acid levels that are 120, 150 or higher. So if you're making a 40 to 50 point adjustment to your total alkalinity, and that's something that's being ignored, you could be testing your total alkalinity at the right range of maybe 100, but your true total alkalinity is 60 or 50, which is actually way too low. I see pools getting spot etched. Customers see their total alkalinity, thinks it's in the right range. However, the water is very aggressive and is damaging their interior finish without them even knowing. So it's important in that aspect that you keep an eye on your cyanuric acid level and make that total alkalinity adjustment. If your cyanuric acid is too high and you're late in the season and you're not draining your pool yet, and you need to make a 40 or 50 point adjustment, it's okay to keep your tested true total alkalinity up in the 140, 160 range, knowing that you're making that adjustment and your true total alkalinity is in the proper range. So if you need to make that adjustment, add the necessary baking soda that you would need to bring it up higher than your test readings are showing, because your true total alkalinity is going to be in that proper range. So hopefully that helps understand that specific little unique adjustment that you make to that total alkalinity. I hope all these tests have been very helpful for you. Gives you a nice brief tutorial on how to do each test. By all means, feel free to give us a call if you have any questions, as you're taking care of your pool and enjoying your pool over the many years to come. Appreciate you watching. Happy swimming.